Hey everybody, Mrs. Bixler here, and we are moving on to our next section in this unit. I know it says section 7.3, and that's because that's what goes along with your chapter in your textbook. So section 7.3, if you look at the textbook, all this info is in there. So let's jump in and start talking about similar figures. So we've talked about figures being congruent, like line segments being congruent to each other, angles being congruent to each other. But when we talk about similarity, I know that polygons are similar if their vertices can be paired up. So I can match up all of their coordinate points so that the corresponding angles are congruent and the corresponding sides are in proportion to each other. So what that means is if I look at these two shapes on the left-hand side, I know that A and E would be congruent, B and F would be congruent, C and G, et cetera. You get it. But then that also means that whatever AB is, the relationship of AB to EF is the same as the relationship of BC to FG. And the same thing is true if it's a pentagon or triangles or a quadrilateral or octagon, whatever. So no matter what the shape is, if you can match up the angles so that the corresponding angles are congruent and the corresponding sides are in proportion, you've got similar figures. So let's look at this. So see these two pentagons. So I'm going to tell you that these two pentagons are similar. And so this is a really important symbol right here. This means similar to. So I know that in logic, this was the not sign. This is also the little sign that goes over the equal sign when we're talking about congruency. But when it's just alone and we're talking about two shapes, it means that those two shapes are going to be similar to each other. And so remember, if they're similar, I know that all of my corresponding angles are congruent. I'm not going to do it all the way around. And then remember, the relationship of AB to GF is the same as the relationship of BC to GH, is the same as CD to HI, et cetera, et cetera, et cetera. All right, so an important way and the way that we figure out what that relationship is between our side lengths is something called scale factor. So the scale factor is simply the comparison of the two sides that you are given. So if I know that these two pentagons are similar to each other, I can figure out what their scale factor is. So it's 15 over 25, and if I simplify that, divide both by 3 or by 5, I get 3 over 5. So my scale factor between these two shapes is 3 to 5. So I want you to keep that in mind, and I want you to pause the video and try and solve for x. All right, we're back. So hopefully you've set up your scale factor first. You knew your scale factor was 5 to 8. And then all you have to do is set up a proportion. So your scale factor is 5 to 8, and it's set equal to 12 over x. And then you solve, and you get what x is. All right. This next one, I want you to pause the video, and we know that these two guys are similar to each other, so I want you to pause the video and solve for y. Okay, we're back. So if you know they're similar to each other, you know that the corresponding angles are congruent. So I know that y has to be 130 degrees. Fab. Hopefully that was super easy for you. Okay, so I have a few side notes here. The first one is sometimes textbooks are lazy and they'll give you a pentagon like this, and then instead of calling this other one pentagon, FGHIJ or whatever, they call it A prime and B prime and C prime. It's just to show you that like these two angles are the ones that correspond with each other. They're just kind of being lazy and they didn't come up with other letters, but don't be thrown off. It's a different A, because if it's A prime, then it's different than that A. All right, the second one is, this is really important. When we hear the word regular for polygons, a regular polygon is any polygon that has congruent sides and congruent angles. So a regular polygon could be a triangle, it could be a quadrilateral, it could be a pentagon, it could be an octagon, it could be a hexagon, whatever. So as long as all the sides are congruent to each other and all the angles are congruent to each other, then it's considered a regular polygon. And the third side note is everything we're talking about is we're talking about convex polygons. So a convex polygon would be one that has diagonals that stay within the polygon. So watch. A diagonal is any line segment that connects vertices that are not the sides. So see how all my diagonals stay within my shape? But if I were to draw a non-convex polygon, like that, for example, let me try and draw my diagonals. All right, so that one stays in, but shoot, this one goes outside. So this is what we call a non-convex polygon. And we're not really going to be using those non-convex polygons because their properties change. So the convex polygons, these are the ones we're going to be using. That's just a good side note. It's something to keep in mind. All right, so last slide. I want you to pause the video and I want you to solve for X, Y, and Z. Go! Okay, we're back. So hopefully solving for Y first. So I just solved for the missing side length. I found out first my scale factor. So my scale factor is determined by finding my sides that match up. So 12 over 10. So 12 over 10 simplifies to 6 over 5. There's my scale factor. And then you just set up a proportion. And so then we know that that equals 8 over y. And so then y is going to be 20 over 3, or 6.66. All right. And then for x and z, see how we have x is going to be 30 because these are the corresponding angles that are congruent. And then you know that if this is a right triangle, you know that whatever is left over has to be 60 degrees because 30 plus 60 is 90. All right. So hopefully you felt good about that. Go ahead and tackle the homework and I'll see you soon. Thanks.